Bro, oh my gosh, we finally got good quality internet, man. I don't know what goes on around here. Need that stream to Twitch as well. Alright. We should be live on Twitch and YouTube. Oh. Alright, I tried streaming multiple times. I have to do like a speed test first, and then I think my router's like, okay, this guy wants speed. He wants speed. Let's give him speed. He wants the speed. You know, he needs the low latency speed. I have to trick my router into thinking it. Yes. Oh my gosh! Look, my stream is finally there. Oh my gosh! It's high quality. Such high quality. Oh my gosh! Wait, what is this? Wait, I don't even know what that is. Anyways, this looks awesome. This looks awesome. Hello YouTube. Hello, Thingy-majiggy. What it's called now? I forgot the name of the thing. Twitchers. You guys Twitch a lot, bro. Oh my gosh, people can get me bids for 20%, 28% off. Whoa. Which is broken for you, man. On my... What's it called? On my thingy. On my, Thingy-majiggy. So broken. Oh, so broken. Twitch is so broke. Twitch is broke. Twitch is like, wait, what the what Twitch? Oh, maybe I gotta fix something to Twitch. Hold on, guys. Very fast. What settings? Yeah, Twitch is supposed to be the same. I don't know. Twitch is broken. Let me turn on Twitch again. Boom. Boom. We turned on Twitch again. But hello guys, my name is Gabs, and it's been lovely having you here guys today. As you can see in the title, I'm not sure if you guys can see in the title, but my AI thingy-majiggy is oh, you can see that way. No, everything's broken. Okay. As I was saying, as you can see, my AI thingy-majiggy is broken, brain dead, very brain dead indeed. And the reason my AI thing is very brain dead is because I think of quantization. I think methinks quantization has perfectly brain deaded the thing. So if we look at the Mistral 7B, now this may be the wrong one, but we'll load it up anyway. This may be a higher version one, actually. Version 0.3. Interesting. If we load this up, let's say to cook pasta. It gives this. It gives this, guys. It gives this, alright? Okay. It gives this. Now, we go here. Get a best friend one. Let's see. How do we get rid of that guy? I hate these cameras. Guys, don't click on that. Don't click on that. You go by. You go by now. I go bye bye. You go. What do we? Got hacked. This is what happens when you're hacked. Alright, anyways, what was I gonna say? Oh yeah, now when you take the same thing here, right, how to cook pasta, you take the same thing with the BFF one. Wait, hold on. Okay, now you see. You see the difference in answers, right? Now I understand this is more of an instructional one, but we do this one. How is the weather today? How's the weather today? Okay, no, let's go this one. How's the weather today? Go. Wait. Hold on. BFF70. On here? Oh wait. Wait. I forgot which one were we using for which thing. Wait a minute. I don't remember these. Huh. I think this one is a dumber one. Actually, well, you get the idea. The girlfriend is dumb. The AI girlfriend is dumb. So we need to fix her up. So how do we fix her up, you say? Well, boys, several things. It's time we look into the main source code and try to see what we can do. Well, first of all, we gotta fix several things first. We gotta actually build the base up, and that means fixing this code thing first. So this is the magistral small. Magistral small is one of the big ones, right? Visual 7B is a small one. Magistral small is the large. It's actually pretty large. So first we gotta run all of this because I was having some issues before. So we're gonna do that. Gonna see what we do, how we go. Now you guys may be wondering, will this not crash the stream? And I gotta say to that, ladies and gentlemen, I have fixed my GPU. The Radeon Pro is back, baby. And this guy here, the GeForce, the RTX 3060, is just for the AI. Just for the AI, but you can see it's capping there. We need we need to do something, but oh my gosh, I'm already using 38. How am I using so much already? Oh my gosh, what? I'm already using 38, only 5 gigabytes of this to Visual Studio. Which doesn't make sense as to why it's using so much already. But as you can see, like, there is quite the things. Oh, and also, I gotta fix my face, guys. Let's fix the face. Calibration. I think I loaded the calibration already, but why is my mouth even bigger than before? Okay, no, now my mouth is fixed. All right. Now, oh yeah, we gotta get rid of the thing. You guys can't see that. The background tasks of daily life of VTuber, you guys can't see that. So now, there was another issue that I faced. So first issue was the computer. Oh my gosh, I'm so tired. What did I do? All right, another one here was that the computer was, okay, now I gotta fix this up, guys. I'm sorry, guys. Settings, expression settings. Where's the thing? No. Settings. General settings. Mouth sensitivity. Mouth size reduction. Okay. All right. Okay. Hi. Hi. Hey, my yawn like really large. That's the main issue. Anyways, that's enough of that. Anyways. Why does it do that? Why is it going out of my body? You can see it. Oh my gosh, it's so... I don't even know anymore, man. I don't even know anymore. I'm too tired for this. I'm too tired for everything. I'm too tired for life. Man, we had some issues before, and having this weird error where now we're having a tensor bug out or something of that sort. But yeah, we gotta fix this up, boys. We gotta fix this up. And we're gonna be using all of our resources today, boys. all of our resources, and I mean all of our resources. We're not sparing a single bit. Look at that electricity bill. Don't worry, I'm not paying for the electricity bill. I work to pay my own hobbies and my own thingies. So oh my gosh, my mouth keeps going. My mouth, it thinks that it's, dude, I gotta fix it. What is up with my mouth thing, man? Like, come on, what is that white bit there? Why do I have that? Why is that my teeth? Dude. Oh my gosh, man. Alright, hold on. Mouth size reduction. 0.21 mouth size reduction. That's it. That should be it. Right? Come on. There shouldn't be any issues now. 0.2 mouth size reduction. Anyways, today let's quickly see. So we're going to be doing a lot of training and also really looking into RAG, and not really RAG, but we're also going to be doing some other things as well as the RAG stuff. So let's start with a new. So we've got the main stuff here. Right? That's all good. That's all dandy. We're gonna need some other things as well. Now, whilst the CUDA is training, it's really fragile. It is super fragile. We cannot let it do anything else. But what we can do is learn about RAG, or actually learn about some things in Hugging Face. So let me get Hugging Face up real quick, because one of the other things was trying to add voice text to speech, right? So let's do that. Text to TTS. No, that's just it. Yes. Let's look at some TTS stuff. Let's look at some zero-shot voice cloning. Clone any use speaker of audio. Alright, so this is good. I wanna know what zero-shot is. What is zero-shot? Zero-shot is just like one of the things that we learned in AI thing, but zero-shot AI. But like, I don't really understand it. Zero-shot learning. Okay, you know what? Let me grab my YouTube, guys. What is zero-shot learning? What is zero-shot learning? Let's grab that zero-shot learning. Alright. Can't hear. Huh? Why can't I hear? Wait. Oh my gosh, he's going to this the entire time.
If you've never seen this specific pen, which is a special marker for lightboards, it shares enough attributes with other pens for you to recognize it. In fact, you and most humans can recognize approximately 30,000 individually distinguishable object categories. Now, to train a deep learning model to recognize objects, we often turn to something called supervised learning, a form of deep learning, and that requires many labeled examples.
Social learning PyTorch
by making
documentation.
predictions on a bunch of labels in a data set. These labels provide the correct answers or the ground truth for each example. The model adjusts its weights to minimize the difference between its predictions and the ground truth, and this process then needs a whole bunch of labeled samples for many rounds of training. So, if we want AI models to remotely approach human capabilities using supervised learning, they must be explicitly trained on labeled data for something like 30,000 object categories.
Just quite a lot.
That's a lot of time, cost, and compute. So the need
it's
for
wasteful.
machine learning
It's
models
horrible.
to be able to generalize quickly to a large number of semantic categories with minimal training overhead has given rise to something called N-shot learning. That's a subset of machine learning that includes a number of categories. So
oh, there's a Geeks for Geeks thing! Oh my gosh, I can finally understand it.
learning, which uses transfer learning and meta-learning methods to train models to recognize new classes. Then we have one-shot learning, which just uses a single labeled example to learn. But what if we don't want to use any labeled examples at all? Well, that is the focus of this video, and that is zero-shot learning, where instead...
I think zero-shot learning would be really good, because what we can do here, right, is that we can automate everything. So let's really look into this, man. I really want to learn zero-shot learning. And just try to do it, because there are several things, like we're going to need zero-shot learning if, you know, to do generalization and all that sort of stuff. If this is good, oh, this is using zero-shot learning, right? Then we can start the cloning process. The cloning process! And then we just need to find the correct voice. I don't know how we're going to synthesize the voice, but we can find it. We can work with it. Work with that. It's data that we can work with. Huzzah!
Instead of providing labeled examples, the model is asked to make predictions on unseen classes post-training. Zero-shot learning has become a notable area of research in data science, particularly in the fields of computer vision and natural language processing. So, how does it work? Wait,
we can do it with natural language processing? Wait a minute. If that's the case, it's gonna be wild. Maybe you can actually do it. Maybe. That's interesting. Let's try it. Let's try zero-shot learning and add RAG into it as well. Let's see how it goes.
Explicit annotations to guide it. Zero-shot learning requires a more fundamental understanding of the label's meaning, because after all, that's how we humans do it. So imagine a child wants to learn what a bird looks like. In a process similar to few-shot learning, the child would learn by looking at images labeled bird in a book of animal pictures. Moving forward, she'll recognize a bird because it resembles the bird images she's already seen. But in a zero-shot learning scenario, no such labeled examples are available. So instead, the child might read a written story on birds and learn that they're small or medium-sized animals with feathers, beaks, and wings that can fly through the air. So she'll then be able to recognize the bird in the real world, even though she's never seen one before, because she has learned the concept of a bird. Just as even if you've never seen this pen before, you can still classify it because of its cylindrical shape, it has a tip, and that it's leaving colored markings when it comes in contact with the glass in front of me. And yes, there is actually glass in front of me. I'm not writing into thin air. Now, what I've described
yes, there is actually glass
is one example of a method of zero-shot learning, a way to implement zero-shot learning. And that method that I've introduced is called attribute-based. So this is an attribute-based zero-shot learning method. That's where we are training on labeled features like color, shape, and other characteristics. Even without seeing the target classes during the training, the model infers labels based on similar attributes. So for example, a model can learn about different types of animals. So let's say it starts off by learning about stripes, and it learns about stripes from looking at images of tigers and zebras. Then it can learn about yellow, the color yellow, from images, let's say, of canaries, and then it can learn about flying insects from, let's say, just looking at, well, pictures of flies. Now, the model can now perform zero-shot classification of a new animal, let's say bees, despite the absence of bee images in the training set, because it can understand them as a combination of learned features. So striped plus yellow plus flying insect, that might equal bee. Now, attribute-based methods are quite versatile, but they do have some drawbacks. They rely on the key assumption that every class can be described with a single vector of attributes, which isn't always the case. So for example, like a Tesla Cybertruck and a Volkswagen Beetle, they're both cars, but they differ greatly in shape, size, materials, and features. Now, many zero-shot learning methods use an alternative method, and that is known as embedding. So an embedding-based approach to zero-shot learning. Now, this works by representing both classes and samples as vector embeddings that reflect their features and relationships. Classification is determined by measuring similarity between these embeddings using metrics like cosine similarity or Euclidean distance, similar to k-nearest neighbors algorithms. And because embedding-based methods typically process inputs from multiple modalities like word embeddings that describe a class label and image embeddings of a photograph that might belong to the same class, they require a way to compare between embeddings of different data types, and that's where joint embedding space can help normalize those vector embeddings. Now, another method of zero-shot learning relates to generative-based methods of zero-shot learning. Now, if we think of the first example of generative-based, we have to think of LLMs, that's large language models. And large language models have a natural ability to perform zero-shot learning based on their ability to fundamentally understand the meaning of the words used to name data classes. LLMs are pre-trained through self-supervised learning on a massive corpus of text that may contain incidental references to knowledge about unseen data classes, which the LLM can learn to make sense of. And then beyond just LLMs, another zero-shot generative-based approach is my favorite type of neural network, and that is a GAN. GAN, that's an acronym for Generative Adversarial Network, and it actually consists of two competing neural networks jointly trained in an adversarial zero-sum game. So there's a generator component that uses semantic attributes and Gaussian noise to synthesize samples. And then there is a discriminator network as well that determines whether samples are real or fake. Fake meaning they were synthesized by the generator. Now, feedback from the discriminator is used to train the generator until the discriminator can no longer distinguish between the real and the synthetic samples. That's perfect for generating synthetic data that mimics the attributes of unseen classes, thereby enabling models to learn from these synthesized examples as if they were labeled. So that is zero-shot learning. It's something you do effortlessly every time you see a new object, and it's something deep learning models can be taught to do as well. Zero-shot learning shows AI's potential to generalize from minimal information.
Oh, we're going to go back to GAN networks. Ah! Oh, this is going to be fun. All right, boys. All right, all right, all right. All right, all right, all right. So we can do. At the moment, thing is still this bit's still going for bits and bytes config. That's still loading its thing up as we speak. So nothing for us to do there at the moment. Zero-shot learning testing. Audio. Alrighty. Save. Okay. Oh my gosh, guys. Guys. Oh my gosh. I have to show you guys this. Wait. Where is it? Where is it, dang it? Hold on, guys. Where is it? Bro, where's the bunny kiss thing? Bro, guys, I need to show you guys what peak is, man. What peak is. Where is it? Where is it? I gotta search this guy up. This is the only reason I use Twitter, man. This is literally the only reason I use Twitter. Guys, check out how peak this is. Check out how big this is. Whoa. Okay, I know this is you know, an educational stream. This is educational. Peak. Whoa. Get the emojis in. Whoa. All right. Anyways, what was I saying? No, yeah, we'll wait for this, and then we'll go into Zero Shot Learning audio as well. Now, let's get a bit of Linus Tech Tips audio. So let me just grab. Oh no, not this. Where's my GitHub? Where's my GitHub? Grab some of this. Let's open up Labels. Let's show an Explorer. Alright. Wait, where is the testing data? Where did I put that? I don't know. Assets. Let's call it assets. Assets. Audio data. So let's call this Zero Shot Learning. Audio sample. Alright, so Zero Shot Learning audio sample. Let us grab some, what's it called now? Let's grab some, what's his name again? Linus Tech Tips, is it? Yeah. Linus Tech Tips. Linus Tech Tips audio. Okay.
You would not learn that I'm about to.
Your fridge is for your family.
Wait, is he live right now? Oh, he is live. Oh, I thought this was a recording. Whoops. Please don't sue me, Linus. Actually, you know what, guys? I got a better idea. Wait. Guys, there is this YouTuber that I really love. What's his name? Forgot his name, dang it. Oh yeah, Mental Outlaw. Is this the guy? Yes. Okay.
CatchyOS is the distro with the most hype.
I love him, and that's why I think it's gonna be funny if we're able to clone his voice and start cloning him. So let me get this downloaded straight away. So let's just go to terminal. I forgot what the code was for. Where's the... I forgot what the thing was. Thingy. What was the code for that thing? Videos, eDrive. My storage. No, that's for that. Videos, is this it? No. Where did I put it? I was... Archive. Is it this one? No. Where did I put it, man? Where did I put it? No, that's not it. Game files, no. Bro. Where did I put it? Did I leave it in my other one? Is it on this? Yeah, maybe it is on this. Maybe it's on this. Recordings, no, that's not it. Movies, no, that's not it. Videos, I do not see my code anywhere. I do not. I feel like I uploaded it somewhere, but I'm not sure where I put it, man. Oh my gosh. Where is my YouTube encoder code thing? You know, just stuff it, man. Just stuff it. Let's just go. Where's my plugin for this? Here's my plugin. We're gonna download, guys. Download video. Download. Haha. Wait. Stop. No, we only want audio, right? Yeah, we only want audio. Stop. Broken. I broke it. Where is it? Open downloader. No, I really did break it. Oops. Uh-oh. What did I do?
Catchy OS is the
Video downloader. Dang it, man! It's not. How do I do in the sidebar? How do I do this? Got. No, I don't need that. Okay, I'm gonna download. Only is MP3. Where's MP3? There's no MP3. Download as download audio. Okay. Not audio. Alright, there we go. Got that downloaded up and ready to go. So don't need a spoof, but use agents with some YTS MX. Is YTS MX? I don't know. Agents. But yeah, we gotta fix a lot of things, man. There's so much work that needs to be done, as you can see. So we'll try to get this part fixed and sorted out first, but then we gotta fix. Maybe Laura Dropouts we could fix this thing. It causes a lot of issues. Lots and lots of issues. We're gonna search up. Oh, okay, we got the Zershot thing. Okay, hide. Wait, no, how do I hide this? Wait. How do I hide this? I broke my thing. Okay. How to prevent AI fine tuning from dummy down the LLM. Why I get down? No, not that. That's not it. Fine tuning making my AI dumb. Wait. Fine tuning making my AI dumb. Fine tuning making my AI dumb for every little thing. Functioning data, everything should be training data matching. Functioning to the most remote objective. Okay. Dang, nobody on the OpenAI thingy. Functioning's been out, well, it's hard to and costly roles better for influencing output size as they don't dumb down the model and see the screen. But we are using loaders though, aren't we? We are using loaders, yeah. So when is this thing gonna load already, man? It's taking so long. What's going on? Look at all that RAM, guys. You guys jealous? Time for it to be used by AI. Everybody hates AI, man. So I'm just gonna put it in your faces, the AI haters. As we fine tune and all that. So let's this is the quantization. So I was looking at the quantization a bit here. Now LLM quantization techniques. We need to figure out why it is getting so dumb. Because it's losing a lot of intelligence. Losing like a lot of intelligence. Now how to look at, well, I have a look at this, right? It's just alpha, wait. Calculation weight updates. I don't know what's going on here. So like, I know it loses some intelligence, but it can't be this bad. You know what I mean? Like, you know, it's horrible. So let's see how it goes first. Bytes config. Quantization causing lots of issues, man. It's not the fine tuning, it's the quanti. What if we reduce quantization? Let's see. Bits and bytes config. Quantization. Let's see now. So it's post-training quantization. Reduce model size without creating required changes during the training phase. Quantization of wherever. But this is, yeah, this is post-training. This is post-training. Use double core. What is double core? Load in 4-bit. True. Then be quant type NF4. What is load 16? Can be type load 16. What is double quants? This is, I don't think this is used. No, it is using double quants. Torch.32, float 32. What if we do 16? Inference training float 16. Calculation should be done in half position. Which is small. Performance and accuracy for many applications. Okay. Vision. Okay, but we're doing something wrong. But I don't know what. I don't know if it's because of my ping, or maybe we need to zero shot the LLM training data. So let's do zero shot audio first. Let's try zero shot audio learning. So zero shot audio PyTorch tutorial. Zero shot audio PyTorch tutorial, guys. Let's do it. PyTorch, Fuchsia Torch, use Torch as a provider for deep learning. Awesome. Oh, audio input, output, Torch, documentation. Alright. Grab all that stuff. And technical terms, waveforms, travel, okay. Amplitude, that includes decibels, frequencies like the hertz, sampling, is getting started with touch processing. Okay, do we have Torch audio? Under install well number Jupyter Lab. Okay, so import Torch audio, that one. So import Torch audio. We'll select the kernel as labels. Should I do it as labels? Would this cause issues? Would this cause like a conflicts if we use the same environment? Would this cause conflicts if we use everything in the same environment? I'm not quite sure about this. should we only have one thing running at a time? I feel like just in case we should probably have just one thing running at a time. Otherwise it might crash everything. Until that I say easy. For the switch command says it's all switch commands for by P. Processing. Oh, load the dataset using Torch Audio. Okay. Okay, so ROM pathlet, import path. Okay. Alright, let's copy that. So import is done on the markdown, so go code. Go this. Well, this part's really here. And this part's really just over here. Torch.datasets. Not P. Interesting. Okay. So, alright then, in that case, what we'll need to do here. Just do fix of imports. Okay, we need to select the Jupyter model. Let's select, let's do that one. In that case, and then Torch Audio.dataset import commands. To run that at the same time as everything is running. Okay, that's ran. It's done. Why is report missing import? Torch Audio.datasets. Let me get my Conda on it. Conda. Wait, yes, can I get Conda Navigator? Yes, you can. Oh yeah. Conda activate lay. The lay lose LLM. No. Wrong one. Okay, clear. I said clear. Alright, let's go to Conda install Torch Audio.datasets. Wait, should I install Torch Audio.datasets? Wait, is this gonna? Oh, wait, okay. Solving environment failed. Channels defaults, okay. So, Islands having errors in the server, okay. Which command is not here? What is going on? How old is this tutorial? Hold on. 2025. Well, where's the speech command thing? Conda activate Torch Audio tutorial. Or should I be put? We did install. Torch Audio is there. Unless I've been installed properly. Of which, to prevent crashing, we'd need to wait for this. Unless Anaconda Navigator. Do a clone. Let's do a clone of the environments. Wait, no, now it is there. Oh my gosh, man, it is. Bro, what in the world is this? Collecting package method. It's like, yeah, all right, it's here. It's here. I'm here. I'm here, Chief. I'm here. All right. Okay, so let's go. Learn path. It's path. But return a path once in its current working directory. It's gonna be a good idea if we do a path in its current working directory. I mean, is it? These commands. Yeah, you know what? Why not? Just to make it. Just to make it good. Oh no, we're doing source, no? We're doing assets. Path. We do it in assets stuff. That's the right thing, so it's it. Yeah, assets. Zero shot. Wait, what is the thing? So assets and then zero shot learning. Zero shot learning. And then. Okay, what about if we do this? Alright, now it's downloading. Let that do its thing. And okay. Let's see. This is still going 9 out of 10. 9 out of 10 thingies, thingies. 9 out of 10 thingies. 9 out of 10 thingies. 9 out of 10 thingies. Bum 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 bum. Man, I feel like I'm really pushing everything to its limit, man. Day. We going crazy hard. Look at that memory usage. Look at that disc. The disc has been on the entire time and the disc is struggling. Oh my gosh. You know, I think I bought this on a discount as well. Because dude, I checked up on the disc, right? And it's like, oh my gosh, it's so expensive now, man. It's like, oh no, I don't want to. No. Yes, remove. Okay. Let's see how it goes. 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 Dude, I don't even know what I'm doing. When you're too bored and you don't know what to do. When you're too bored, okay, it's finally done. Alright, so now we were having issues with this before. Okay. So the QSL triggered, kiddo blocking one. Wait, what is this? This is different. Wait, what? This is different error. There's too many actives and only subset features, but we would like to add node modules. Many active changes. I don't know what this is. First kit. Node modules. What is node modules? To ignore. What is this? What do I even do? I don't even know. Yeah, now we're having weird errors. Kernel might be integrated to the reporter also. Some of the kernel shows errors. So the stack trace might be incorrect. Okay, for debugging. Compile if torch could device. Okay. Well, it's because we have this running. Maybe that's why. Maybe because we have this running. But I don't feel like. What is this, man? Computer error. Device asset set triggered. Computer error. Device asset triggered. Could between number of labels and outputs in your model or incorrect inputs for the loss function. So ensure that your hello matches the number. Okay, yeah. So same. Suddenly getting this triggered. The only issue, I understand what's going on here, though the only issue is that how do we edit the internal thing? How do we edit this internal thing, man? Because this is, where can we edit it? How do we edit it? We are loading all the right ones, right? Matrixel small. Let me re-download this again. Let me just re-download this. Hugging face. Alright. Matrixel small. 2506. No, 2506, please. 2506. Oh, should we do 2509? I don't know. Base model. Yes. So clone repository. Git clone. That's that. Like that. Go here. To the git thing. Where is it? Matrixel small thingy majiggy. Alright. Show in Explorer. Let's get rid of that. Open in. What do you mean it's open in? Oh my gosh, man. Okay, we gotta nuke the thing or what? Fun code. Yeah, we gotta nuke the thing. Gotta nuke this runtime. Restart. Clear all outputs. Done the kernel. Okay, now we can nuke it. Come on. Come on. Now we can nuke it. Come on. Wait, maybe we shouldn't nuke it. There's some. Oh, we need to keep tokenization slow. Oh, okay. Old one. We'll just call it the old one. Dang it. It's compared to the branch in Prince content. I don't know. Origin. I don't know what's going on, honestly. This is weird. Maybe it's this one. Let's do 8. 15. 8. try running all of this again. Unless something to do with the merged models. No, wait, that's after. Wait. Yeah, that's after. Why is this happening, man? Batch size problem, I'll say. Might be an issue. Oh, actually, potentially problematic operations. In shape before. Repeat into shape. Into that shape. Actually, yeah, let's do that. Let's get this stuff sorted out real quick. We'll make it 816. In the meantime, while this is loading, let's get ourselves to short learning audio. So this is done, right? Yes. So that's done. So this and then this. That's all good. Get ourselves in short learning. Where is our thingy? Mastery 2. Where is it? Here you go. Okay, let's cancel this. Let's cancel this. This. What we're gonna do is that we're gonna get started on this one actually. Ah, it's too much thingy. Alright. Let's start with a minimum viable product. So, what is the minimum viable product if possible? With desire one GLM. Let's go and download that. So, clone repo, grab that. What is GLM? Yes, I guess that's just a name. General language model. Reinforcement. Group is a group algorithm, generation strategy. CTTS, and then ours. Okay. Quick start, quick clone, command line interface, shell scripts. Okay. Alright, let's download G thingy TTS. Let me just see if I can add that. Clone repository with an URL, TTS, and clone. Alright, time for my internet to struggle as well. Everybody's struggling these days. Everybody's struggling. I'm proud of my computer being able to keep up though. I'm really proud and happy. My computer's a good boy. He's a good boy. He's a good boy. Actually, no. Let's go with Shiro. Guys. Shiro. Wait. Shiro. No! Dang it, man. Every time I open YouTube, there's always like something on the floor. Pull-up needs to be like this. Shiro. What is it called? Shiro. No game, no live audio. Let's go with that. Dang. Do I have to grab it from the alternative side? Alright. Let's grab it from an alternative side. Is this? I don't even know. Where would we? We'd have to. Okay, let's not do Shiro for now. But I want to hear Shiro audio actually. I want to see if it's good. Shiro no game, no live audio. Wait, English. Wait, there was a dub. There was a dub. I know that there's a dub. No life. No game, no life. Here it is. I know there's a dub. Aha! I see there is a dub. You see? But maybe Shiro doesn't speak much, but that might be an issue. Wait, I can't play this on the stream. I'm gonna have to mute it. I'm gonna have to mute it for you guys. Sorry, guys. I play it on stream. Otherwise, I'm gonna get in trouble for copyright. Okay. We need to dissect this. Okay, maybe Shiro is a bit. She's cute, man. I love Shiro. I love Shiro, guys. She's cute. Don't get me wrong. But I don't know. Let's try a different voice. Let's try a different voice for the AI girlfriend. Whose character should we do? What is the best lolly out there? Jufufu! Let's go. Wait. Jufufu. Audio. Wait. Let's go Jufufu, guys. Bro, we need to go Jufufu. Okay. We need to go Jufufu. Jufufu audio. Jufufu audio download for AI training. Sound like for AI. Jufufu character demo. Dang, no, we gotta download our own. No. Okay. YouTube, YDL, YTD, YouTube. What is YouTube? YouTube. YouTube DL. YTDL. What is that? YTDL code. I know I got my code here somewhere. YTDL. No, where did I put my code, man? Dude, where did I put my code? Oh my gosh, dude. I put my code here somewhere and it's gone, man. Somewhere. Oh my gosh, I found it, guys. I found it. Okay. So. Alright. So. We're gonna download the audio only. Just do this code. So let's see. Audio only sample. Audio sample. Jufufu. Jufufu. Okay, so let's grab the text document, download code for audio. YTDLP FBA. Let's use cookies from browser Firefox. This actually, let's not do from browser Firefox. Let's go with that, and then that, and then here inside here we can do this. Open in terminal. Wonderful. Let's go here. Okay. YTDL. Dang, YTDL is not recognized. I'm gonna download YTDL. Dang. What? The Windows or exe. Pip install, upgrade, YouTube. Yeah. Please pip install YouTube. Yeah. Do I have to use thingy again. Anaconda. Anaconda navigator. Anaconda navigator. Anaconda navigator. YTDLP. Wait. How to install YTDLP for Windows. It should be automatic though. I don't know. Official room. Yeah, they can run the command from Windows game. Installation YTDLP wiki. Okay. Now we don't need that. So close real quick. So instead of this, the Windows one, pulling the release binary file. YTDLP. Okay, now we got the YTDLP right. So it's done. Okay, now what we need to do is how do we make executable? There we go. Yay! I knew you would get Lex. We're gonna do some batch downloaders, ladies and gentlemen. Batch downloading. Okay, let's go to the. So now we should be able to do YTDLP on the command. So let's do clear. We should be able to do it. So yes, it works now. Wonderful. Thank you so much. We can get. Let's do YTDLP. Let's do upgrade as well. We'll just install it actually, so there's no need to upgrade. But what we'll need to do is that we'll need to create the Jufufu library. Jufufu audio. We'll need to create a library of Jufufus, guys. A library of Jufufus. So let's. Oh, it's gonna be hard. It's gonna be a bit of manual. How well we can do it with 10 seconds, right? If we do zero shot learning with 10 seconds. But maybe if we add more, it'd be even better. Let's see this one.
I'm a senior of Swabian Temple, Tiger Thyron Jufufu, the righteous heroine Master Ju.
But I want the roar. I want this one though. She's so cute and funny, man. I love Jufufu, man. I love Jufufu. I play her all the time. I love her. I love her so much. She's absolutely so amazing. Zhao, Jufufu, Nekomara. Bro. Wait. Oh, actually, this might be good.
Listen to my roar! I'm scary and fierce. Wait, let's finish this. Listen to my.
Okay. So. Okay. Let's download this one. Let's copy video URL. Go here. Oh, sorry. Go here. Wait, I'm downloading in the wrong place. Wait, I'm downloading in the wrong place. I opened it up at the wrong place. Uh-oh. The Jufufu here. Open terminal. Jufufu. What'd you do here? Put your shorts there. There we go. Okay, now we download. Okay, that's all done. No, that's horrible. That's a shorts. That's a shorts video. That is not good. Right.
People keep mistaking me for an orange cat tyrant, a Siamese tyrant, or a Maine Coon tyrant. But I'm actually super scary. I'm a big...
She's orange cat certified. Oh man. She's orange cat certified, guys. Oh man. No, that one's not got thingy. I need more Jufufu. Wait. Jufufu voice lines. Jufufu's voiceovers. Oh my gosh, why didn't I think of this before, man?
I'm Jufufu, disciple of Yunquei.
Oh my gosh, it's even better quality. Okay.
I'm Jufufu, disciple of Yunquei Summit.
Oh,
yeah, that sounded pretty impressive, right?
Dang it, we'd have to do.
I do look pretty fierce today, huh?
Jufufu! My Jufufu! Why must you be so cute and funny? Whoa! Jufufu. Okay.
I'm Jufufu, disciple of Yunquei Summit.
For this one.
Yeah, that sounded pretty impressive, right?
I'm gonna choose the mod for this one. Where is the thingy mod? Because we can't download it, right?
I'm Jufufu, disciple of Yunquei Summit. Yeah, that sounded pretty impressive, right?
Let's go to this thing. Did I download a helper? Waiting for media.
I'm Jufufu, disciple of Yunquei Summit. Yeah, that sounded pretty impressive, right?
Come on, work. No.
Before our heroic adventure, should we order 3 servings of pork ribs with bean sauce from Yumchasin?
Let's go this one. Let's go here. Let's go here. Inspect.
Before our heroic adventure, should we order 3 servings of pork ribs with bean sauce from Yumchasin?
Autoplay. Where's the audio?
Before our heroic adventure, should we order 3 servings of pork ribs with bean sauce from Yumchasin?
Alright, let's go. This save audio as. This thing's not picking it up. Why is it not picking it up though? Missing media. Downloads and notifications. Down quality. Okay, downloaded. Put on industry.
Before our heroic adventure, should we order 3 servings of pork ribs with bean sauce from Yumchasin?
GG. Okay, so in that case, let me quickly grab the Jufufu thing. Maybe delete these actually. Yeah. Delete these because we got even better samples here. So open that up. Save that. Okay, that one's done. Now do it here.
Before our heroic adventures, I'm Tufufu, disciple of Yunquei. Before our heroic adventures, should we... Hey, don't look down! Before our heroic adventures, should we order 3 servings of pork ribs with bean sauce from Yumchasin?
Wait a minute. Wait, is this all the same?
Before our heroic... I'm Tufufu, before our heroic adventure. I'm Tufufu, disciple of Yunquei Summit. Yeah, that sounded pretty impressive, right?
Specs.
I'm Tufufu, disciple of Yunquei Summit. Yeah, that sounded pretty impressive, right?
Okay. Then...
Hey, don't look down on me! I'm a senior disciple!
This is gonna make one wheeze!
Fufu's here!
It's too cute! Yo, Fufu! Yo, Fufu! You too cute, yo, Fufu!
Fufu's here!
Oh my gosh, man. Oh my gosh.
Fufu's here!
Yo, Fufu.
Today's reading is Be a Hero.
Okay, inspect. This.
Today's reading is Be a Hero.
Oh, okay.
Leave it to Senior Fufu. Yeah! Lihua! Yunquei stands. I've been preparing for this moment. I'm not scared. I've let every... Hey, Junior Belle. Why are you staring at me like that? Did I get something on my face when I was eating?
Oh, no, Fufu.
Why are you staring at me like that?
Grab some of the biscuits.
Did I get something on my face when I was eating?
So let's grab that. It's upcoming.
Shifu always said that plants have feelings too. I hope they forgive. Whoa, they want me to take the lead? You really have faith in me, huh?
You're too cute, Fufu. You're too cute.
Why are you Who are you waiting for, Junior Wise? Who are you waiting for, Junior Belle? You're not your usual energetic self. What's wrong? Not feeling well?
Alright, so let's attach all of these together. Do we need to attach it all together? Let's check the manual for this. So that's our training data. That's our raw training data. Now we need to go back into... Where is the thing? I lost the thing. Where's the hugging face thing? Good face, here we go. Alright, so... This says... a llama-based approach. Okay. Go to the thing. How do you use this? So, pip install. Okay, that's already done. Wait, what is theme and capabilities? What is this? This is sound primarily regarded by speakers of the language of single base sound. A small photo for a key that helps distinguish one word from another. Okay. Alright. Let's see now. How do we actually run this thing? Running the inference demo. So, inference example. Let's set H. Don't know exactly the specifics here. This is the inference thing. Okay. Let's see what we can do. Let's see. Alright, let's try and see if we can do this. So we go here, open in terminal, grab another terminal, and let's see if we can do... Oh, but where's the location of the thing though? Oh, actually we got a weird interactive web interface, let's go. Radio app, radio.app. Let's see, gradient on that. I don't know. Let's go to the... Where is it? Here. Show an explorer. Here. Open. Here. Here. Let's go to gradient.app one. See how that goes first. See the results. Python tools.gradio.app. Huh? Well, that's not good. No module found. They should have fixed it ages ago. We'll do Python GLM. Okay, let's run the GLM TTS inference.py. Will not open. Such file a direct copy. Interesting. LS. Huh. Oh, that's interesting. I'm sure I... Oh, okay. They've done it differently. So which one do we need to run in that case? Read me. Open. Not opening. Oh, I know it is. Okay. Okay. Speech tokenizer? No. LM? No. Which one are we running? Huh. one do we run? It is. Focus studio? No. I'm confused. I'm confused right now. The same thing. Clone this repo. No, this is the wrong one. Not this one. Did we clone this repo? You can see it within clone this repo. What did we clone then? Files and versions. Well, a month ago. Okay. So we would need to be inference, the GLMTS inference one. Okay, but there's no GLMTS inference thing. Getting it from the hub thing. Alright, so we need to get it from the GitHub specifically. By the looks of it, yeah. Unless... yeah, we'll get it from the GitHub. Okay. Alright. GLMTS. Well, here's what we'll do. We'll just let's remove that, the old one. Okay, maybe we can't. Add, let's go this. Let's try to remove the GLMTS one. Okay, remove. I said remove! It's not working. No. Alright, let's go. Yes, I know we can only contain the empty folders, which is what I'm trying to do. I'm trying to remove those empty folders, but you won't let me remove those empty folders. Okay, what if I just try and get rid of everything? Okay. Well, that works. Okay, then in that case, what we can do is download this. Yeah, we can go back to GitHub desktop and add clone repository URL there. Contains files. Oh my gosh, I gotta delete the whole thing. Come on. Open in another program. Why is it like this? Is it like this? View, then files, git one. Okay. Oh my gosh, finally now. Come on, now we can delete it, right? Okay, no, can't delete it. At least we were able to delete the contents of it. So now it is fully empty. Now we can add the git clone repository. Okay, clone. Alright, now it's cloning git. So now we got that being cloned up and ready to go. And our thing's been doing pretty well itself. Show an explorer. Wonderful. Alright, so now we got the inference stuff. We should also have the utils thing. So if we go here, open terminal, right? And finally open up the terminal. And then on this one, what we can do is that we can go back here. We can run this code. We should be able to run this code. No, we cannot run. No module named Gradio. Alright, so we're gonna go here, gonna go Anaconda. Environments. Hyphen. Let's go, voice synth. Let's call it GLM-TTS. GLM-TTS. Okay. And create. Alright, so that's being created. And while that's being created, we should then, after this, be able to go to Conda, activate GLM-TTS. Once it's been made, of course. It's getting there. It's getting there, boys. Man, it's taking a while. Oh no, it's done. Alright, so good. Activate this. Wait. No, we're in the thing. No, we need to go to. Dang, man. We need to go this. Bum bum. CD. Oh wait, no. Wrong one, CD. Okay, LS. So let's go Conda install. Is it Guardio? Wait, no. Conda install, what is it? Conda install. Conda install. Tools.gradio app. Pip install Gradio, okay. Conda install Gradio. proceed? Yes. What even is Gradium? I don't even know what Gradium is. Come on, are you done yet? Still going. Still going. I think it's taking a while. Alright, that's done. So, let's then... LS. And then... activate... Ah! Honda install torch, please. Ah! What is this? No much online torch. Pip install torch. There we go. There we go. Wait, maybe we should just do pip install r/requirements. The requirements folder. Wait. Where is it? No, this. Pip install r/require.txt. Should have just done that. I should have just done that. I'm so dumb. Why didn't I just do this? Bruh. I feel like I need faster Wi-Fi. Maybe it's time to upgrade to the 2 gig. Just maybe. What? Uh-oh. Uh-oh. No! What happened? No! What happened? Peace. Why? Okay, can we just run it normally? Come on, what else do you need right now, man? Oh my gosh. What else do you need? Hurry up. What is this app? Why does it bother me with pip install info? Come on. Come on. We can try again. Let's try again. Hopefully this works, man. This is insane. Okay, why is... Oh no. Oh no. You have to create a command for it. Wait. Pack installation. Okay. Okay, now it should be good. There should be like a thing, man. Like, dude, this should be by default. I don't know why this isn't a thing. Like, if you want to skip it, you just skip it by default. Just install everything else. Forget about the things that don't work, you know? Dude, I thought... No, just skip it. Ah, skip. Okay, I see. Okay. Even this is still having issues. Oh wait, no, I'm reading it wrong. The days feel less. Things get. Oh, FPS is dropping. FPS is dropping. What's going on? That the FPS is dropping. Sudden frame lag. Sort of rendering issue. Oh no, everything was just locked in there. Man. Why is my... Oh, the mic. Bro, this is taking so long. I'm gonna food, man. I'm gonna make some food or something. I don't know. I'm gonna grab some snacks or something. I'll be right back. Grabbing snacks. Yabby. Alright. Be right back, boys. Be right back. Took me 10 years, guys. 10 years, but I'm finally back. Hey. Let's see what we can do here to fix this all up. Fix all of this mess up. Yeah. Let's actually just... No. I don't know. Let's I'm gonna put on some YouTube videos while we work. I'm gonna mute it though so you guys can't hear it, but yeah, so let me just put some YouTube videos while we work and try to do this. I don't know. That's all running. Okay. Thing. Access. Okay. Local host. Alright. Okay. Okay, guys. Got a thing. Look at this. Thanks. Unload. Upload. How do I upload? Upload. Where's our Jiffy? Huh? Got audio here. Fufu's here. Right. Okay, so that's why it wasn't working. Loud. Wait. Only AC, wave, WebM, Opus audio. Okay. We gotta do some thingy things. Thingy, me. And a break. On la na but it's also titles found. What? Minimum title duration. Preferences. Where's the minimum title duration? Maybe it's alright. Audacity. Ah! Skip for now. Fufu's here. How do I? Okay. All right. So, let's see. Let's do dot wave. It's dot wave. Yeah. Wave. Wait, can you do? We do dot wave. Save. Whoop. No, wait. Okay, wait. Save this one in. I'll do this one. Fine, save it to desktop first. And then this one. Export audio. Don't show again. Okay. Go to browse. Browse to Fufu. Combined audio. Alright, and then go exports. Better exports. Oh, so cute. All right. Okay, that's done. Okay, here. Yeah, try and find wherever I put that file. The dang file. Where's Audacity? It's Audacity. There you go. Okay, let's go to the thing and put down the TTS. Okay. Oh, wait. Prompt text. Oh, there, man. Nice. Okay. Audio. Wow, can I load the speech organizer if you're trying to load it from? Make sure you don't have a look at load the same name. No! What is this? Oh, great. Do VRAM first, actually. Text is empty. Okay, we gotta go back to the Jufufu thing then, in that case. Where's Jufufu's lines? Jufufu's lines. Here we go. What exactly did we download, man? Where is it? Bind audio. Obtain agents. Okay. Beautiful lines. So text. So, first one. Okay. I'm Yufufu. Where's the one? Okay, this one. No, what? No. Get rid of that. Remove. Control C, Control V. And then the next part, let's see. Okay, that's done. And then this one. Okay. And then it was this one. Okay. And then let's go with where is it? Where's the other thing? Definitely does seem like she says, hey, hey, you're right. No, it's not, never mind. It's not. So this one is definitely this. Okay, this one is this, so this one. Okay, this one is that. Alright. How are we gonna like how do you put that into text? How do you put that into text? How do you put that into text? Lines. Let's see now. Let's see. Where's the one that says Fufu's here? Here. Right. Okay. So it's gonna be that one. Here and then boom. And after that, what is the last one? Okay. This makes the work so much easier, man. Just copy Fufu's things. Copy this. Paste. Alright, so that's all of that. So we can go back to here. So in can't load control, so if you were trying to load it from, sure you don't have a local. Oh wait, speech tokenizer. Okay. Do you have a speech tokenizer thing? Wait a minute. Certain. But it's failed. of ZKPT. ZKPT. PPT. No, I want it. Is this one of the things that we're having issues with? I think. Custom place. What if we reset it? Reset this all. Generate. We can't do it. Switch to ZK. Uh-oh, that's not good. Why do I initiate on the 25th of the... Uh-oh. Oh wait, GPU version of Onyx runtime. Also configure the GPU string export. Version of Onyx runtime. Pip uninstall. How do I do pip uninstall again? Pip uninstall. So let's go here. Go here. Let's go here. Closing the server. Good. So pip uninstall. And then let's go here and do that. Yes. Okay. Now we need to do pip install this one. Yes. And then that'll download. to download. That is say it will never download. Now we'll go this. We'll run the server again. I get that running. Alright, let's go here. Right. Still having an issue. Trying to load it from. That's fine. Already taken that from checkpoint directory. Okay. Let's go to this. Go to this. What does it say? Do you need to edit it? Config JSON file. So if we go configs escape et. No, I don't think this is it. Where is this? This is weird. Where is this thing? Config.json file. Where is the config.json file? Front end. No. Examples. No. Where's the config.json file? I don't see a config.json file. This is this one. Is it this one? This is the LoRa config. Gaussian. No, that's not it. Oh, trap at 0.1. Interesting. Where is this? Enter can't load the configuration. There is no configuration. I need to see if there's an issue here. Bell to Translate. Translate. Wait, translate. Translate. It's a female and the gaming experience download. Okay. Oh no, it's in Chinese. I can't read Chinese. Aha! Huzzah! Oh, that's a translator to it. Don't worry. Come on, where's the thing? Hey, where's the thing? Come on. Is it the owner? Is Jin? No. Is he the owner? No, he's not the owner. But where is the thing? Okay. All right. This is painful. Can't get any info or anything. Issues. Oh my gosh! I'm having the same issue. Wait. Hold on. What's this? Hold on. Interesting. Okay, wait a moment, guys. I need to do this. Come on. Oh, Control C, sorry. And then this. Thank you. And then this. And then this. You know, I love how we're on the breakthrough. Like, dude, it's like it's exciting. We're on the breakthrough of something where everybody's having issues with it. It's just so new and everything, man. It's just so new and everything. Afternoon, also saying just looks like it's in Gradius 6, so looks fine. Gradius 6. Ah, okay, this is having issues. That's okay. That's okay. That's okay. That's okay. Oh, this maybe so. All right. Can't be installed on Windows. Another one. When we technical one, Windows cannot be installed. Here in a second next step. Not 24. Loading HRT from or roll from CKPT. Where is the CK from? Where is located CUDA? CKPT. CUDA checkpoint. CUDA checkpoint utility. Okay. How do we do this? CUDA checkpoint. Weapon cell, good at checkpoint, good at toolkit. Okay. Let's run it again. See how it goes. Wait, there's something similar. Oh my gosh, wait. Oh no! One answer. No! 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 Do you need to pull into the direction contains those files, not the specific files, okay? Between the target and sit down below the path and place file. Tokenizer. Okay, well, where is the tokenizer? Can't find it. So, okay, I'll look into the tokenizer. So if we go LLMs maybe. No, if we go tools? No. We go configs. No. Assets. No, this wouldn't be it as well. Where is it? What is this, man? Why is this so hard? I just want it to work. Come on. Utilities. Utils. Wait, speech control for reconstructed switch. Speech control. Modules, no data, no. Prompt speech, wait, no, that's not it. Settings, no. No, that's not it. No, that's not it. No. Wait, maybe it's in Hugging Face. Wait, did we? LMTS. LMTS, Hugging Face. TGS. Container speech tokenizer. Speech tokenizer. Yes. So what do we do here? We just need to download it. Why isn't it pointing over to the thing? That's weird. But it says CKPT though. But how do we combine this? So is this all in CKPT or what's going on here? We download the file? Can we download it as? Let's go to the model card. Let's install. Let's just do this. Got a good idea, guys. Watch this. I'm smart. I'm smart. So, okay. Whoa. Okay. This would have been nice if it was in the documents. Oh my gosh, man. Activate. What's it called again? G LM TTS plus under install now pip install Hugging Face Hub and Typer Lim. Okay. Alright, let's grab this one. Clone repository, git clone, HF download this one. Alright, this is gonna take a while. No, you can't cheat like that! You have to go the same speed I'm going. You can't just fast forward time. No. Let's just go from here. Let's just go torch. Alright, let's go PyTorch. Let's just go back to basics. Nothing is working, dude. We'll just go back to basics then. PyTorch. Let's start locally. No, wait, what are we doing? No, hold on. No. We're gonna restart this. Do this. Lay blues from scratch. So, let's grab new file. BFF LM scratch. Alright. BFF LLM from scratch, and then this one is RPYB. So, BFF LLM from scratch. No. Go. Alright. I'll mark down code. Let's go. PyTorch documents. PyTorch open. Let's just go back to basics, man. Just have some fun with it. Every time we try to do something with other people's stuff, it's just we can't do it. It's just horrible. God. Let's just go back to the basics of PyTorch. Quick start. Alright. Don't need this. Start. Labels. Touch text. Download training data from. Alright, this is VP. Well, I want to create LLM, not this. How to handle corpus in LLM. Where's the thing? How to handle corpus data in LLM. How to handle corpus data LLM. How to handle corpus data LLM. PyTorch easily. It's gotta be a PyTorch function. This, right? Right? Wait. How to build LM PyTorch using corpus data. From scratch on ChatGPT like. Okay, from scratch using. Guys, we're gonna read a book today, guys. Oh, wait. Oh, that's just a book thing. Okay. Alright, where's the free stuff? I just want a normal corpus. Let's build normal corpus. So you need to prepare data by cleaning together the text and defining the model architecture. Let's go Hugging Face. Hugging Face. Hugging Face, Hugging Face, Hugging Face. BFF LLM from scratch. So... source. Source. Okay, let's get Hugging Face. Let's grab datasets. Let's grab something. Documents. No, text. Let's go. Ultimate Offensive Red Team. What is this? Oh my gosh, it's Wikipedia. Oh my gosh, this is Wikipedia. Okay. Files and versions. Let's see now. That's a lot of data. How do I... 71.8 gigs, alright. Let's go here. Assets. Assets, not really set. Data sets, we'll create a new one. Data sets. Okay, so data sets. So, okay. LM PyTorch Scratch. So we did it differently with this one. So, 34 lessons. Base model 2 Pro RLF. Free code camp! Yes! Let's go. Oh my gosh, wait, there's actually somebody in the chat. Wait. Oh my gosh, there's actually somebody in chat. I didn't realize. Hello! Hello! Hold on, I didn't see you. I'm sorry. I got two screens. I need another screen. I need a third screen. Hello there, Kevy. I'm here with you for moral support, but I'm also in the middle of debugging someone else's code to get clip working, so help you find an answer. So I didn't realize somebody was actually talking. I do need to look into a better TTS solution in the future, so I can check out GLM TTS, see if I can make progress with you. That is the statement in the event. You happen to catch these messages when you manage to get any TTS solution working yet? Oh my gosh! I didn't realize somebody was actually here. Kevy! No! I came up with that TTS thing, Kevy. Because I couldn't find out how to work it. I spent hours, I think like more than half the stream, hours just trying to get it to work, and it's like almost a 4-hour stream. But well, I did eat lunch as well in between, but my gosh. Alright, let me know if you can make progress, man. If you want, add me on Discord, man. Here you go. Get Rail 16. Add me on Discord, we'll work on this together. To be honest, I don't know, man. It's just like everything's breaking. I've given up trying to do it. Like I just want everything to just work, you know? But nothing works. Lack of documentation. Like man, it's hard. It's hard. So thank you, Kevy. I wish you all the best as well, Kevy. I wish you all the best as well. I hope one day you know, we'll get it to work. One day it'll work. One day it'll work. Alright, at the moment, I just want to make my own LLM at the moment. We'll just start by, because I can't fix up Magistral. For some reason, like there's no way for me to, you know, everything's the same with Magistral. For some reason, just suddenly just wouldn't work. I'm just gonna try and make my own thing and then use the code that I made, like the saves data thing and all that, so that I can add to the thingy, what's it called? LM Studio. Yeah, that's how you pass the filter thing. That's how you know you've passed the filter restrictions, but since we're making our own, we're not gonna need that. So, yes, we'll get everything sorted out. I'm gonna grab a drink. I'm thirsty. Well, not thirsty. I need to grab something. Wait. I'll grab a drink real quick then. Before we get into the next deep dive. I spent hours trying to make it work, but still. At the moment, if you guys want to follow along, there's a 6-hour thing here from Free Code Camp, guys. I'm gonna follow along because, yeah, let's get this started. And be right back, man. Be right back. BRB, guys. BRB. Wait, I need to go transition. Getting drink. BRB. Have you managed to get into your solution? Can you? But dude, I hope you know that you did good, Kevin. You did good, Kevin. Anyways, BRB, I'm gonna grab a drink before we go into the next stage and watch a 6-hour video. I got all weekend, boys. All right. I got some Coke Zero Sugar. Let's do this. Again. All right.
Architecture and training a tiny language model. From there, you will modernize and scale the model with production-ready enhancements like ROPE, mixture of experts layers, and mixed precision training. The course then transitions to the full alignment phase, where you'll implement supervised fine-tuning and build a reward model. To complete the lifecycle, you'll use Proximal Policy Optimization, or PPO.
I don't want it. I want to use Zero Shot. I want to do Zero Shot. I want to do Zero Shot. Come on. I want to do Zero Shot. Actually, let's see what data we have to work with actually first. If we can get data in Hugging Face that is workable. Get data that's workable. Then we can potentially get text. Let's go. Let's go. Let's do this. Salesforce. Actually, I don't know about Salesforce. Let's not do Salesforce. I wanna have to think about work. Let's do this. Can we go into here? .ab. Oh, I don't know how this works. This is gonna be alright. Not actually a text itself, is it? I want text. Find stories. .j. Find translations. I want databases. That is final web is too much. That is just. Let's get CSV. Awesome chat GPT prompts. Actually, no, not CSV. Last time, when I was in university, we used different sorts of data. Getting the data thing is really important. How you use the data is really important. Okay, let's see. There's like an alien one as well. Come on. I'm trying to find something good right now, guys. Harmful data set. Let's do. Okay. Alright. Okay. Alright. We can do Wikimedia, Wikipedia. But this is literally just containing clean articles of all languages built from Wikipedia dumps with one subset per language containing a single training split. Data visualization languages. You can find a list of languages here. No. Okay. Okay, what about if we just do documents? Let me go back to Geeks for Geeks. Zero shot learning, Geeks for Geeks. Let's look at the steps first. So, Geeks for Geeks, zero shot learning. So we are first. Okay, how do we do zero shot learning? Deep learning. I want LLM. LLM, please. LLM. Shot learning. No, where is it? Instructions. If we can get short prompting. Okay. Okay, zero shot prompting. Start zero shot prompting. Provide prompt describing the task. Send the prompt to the LLM. Generation prompt. Evaluate and output for gen. Simple. Bad examples. This approach falls under zero shot learning. Use a query task. Model processing generating output. World Mount Everest. Classification, laptop, visual feature prompting. But I don't want to do that. I want to do this. Advantages of this. Because. Okay. Where is the one? Oh, we had it before, man. N-shot learning. Here you go. N-shot learning, zero-shot learning. So. Okay. So. All right. Okay. So. It's there. It's different with this. Let's make our own. Okay. LLM from scratch. Very first one. LLM from scratch. So we need that as the basis according to every single information that we can find here. So we'll get an LLM working and sorted out. So if we go, just give me a moment, guys. Oops, not me. Not a robot yet. So let's go. This one. What do we need? Where's the instruction manual? Oh wait, no, it's a YouTube video one. Wait, which one? YouTube video? Where's the YouTube video? Nope, that's not it. Nope. Wait, where is it? LLM from scratch.
To align the model with reinforcement learning from human feedback. By the end, you'll have the deep hands-on experience needed to build and customize your own LLMs.
Hello everyone, and welcome to LLM from Scratch, a hands-on curriculum.
Oh wait, he's got the thing. Where is it? Code. GitHub thing. Thank you so much, Mr. Coda. Okay, he's got the whole code. Wonderful. So, this is the kind of create stuff. Alright.
PyTorch. This is going to be a long, practical journey where we build modern large language model components entirely from scratch, one step at a time. I'll be speaking at a fairly slow pace, so if you're comfortable, I'd actually recommend watching this video at 1.5 times or 2x the speed, but just do whatever feels natural to you. So why this course? Now there are many tutorials that show you how to use large language models. There are many who show you how they are built too. So the likes of Umar Jamil, Sebastian Rachka have all been a source of inspiration to me to learn how
There's barely
LLMs
anything,
work.
man. There's barely anything.
And they've built some superb material around this, and I highly recommend you check them out as well. The objective of this course, however, is to show you the end-to-end workings of modern LLMs in one place through code. We will use the minimal necessary force when it comes to theory. And this course will start from the absolute foundations, how transformers work, how the attention is computed, how to train a tiny toy model on your laptop. And then, step by step, we'll add all the modern tricks, rotary embeddings, RMS norm, mixture of experts, supervised fine-tuning, reward modeling, and finally reinforcement learning through human feedback. By the end, you won't just know how to run a model, you'll understand the building blocks of what makes models like GPT work, and you'll have implemented them yourself if you follow along. Now, let's talk about setup.
Alright guys, if people want to follow along with me, here is the link to this, guys. So feel free to follow along with me if you like. People on YouTube, just search up this guy. People on Twitch, I sent it before, but people on YouTube, where is it? Watch this one here, this guy. LLMs from scratch, from Pro base model to Pro RLHF. Guess that means Hugging Face, which means you can actually load it to this thing.
The requirements are actually pretty modest. We need a laptop with Python, PyTorch, and optionally CUDA if you have a GPU. But a GPU is not mandatory to follow along. You can do everything that we do here on your CPU itself. They just run slower. Here's how the course is structured. So we'll start with part 1, the core transformer architecture. We'll implement the core transformer architecture from scratch. The attention heads, the multi-headed attention, the feed-forward layers, the positional embeddings, the layer norm, and stacking everything into one block. Part 2, we'll actually train a tiny LLM. We'll do this on a small text file, but we'll do all the bells and whistles around the tokenization, the batching, we'll understand the cross entropy.
Yeah, you know what? That's one thing I just realized. A lot of people don't do things small at first. Even I forgot, hey, I should do it on a small scale at first. Actually make a minimum viable product first, before going ahead and grabbing the whole Eiffel Tower. Let's make a minimum viable product, guys.
Together. The sampling and the evaluation part of it. Part 3 will modernize the vanilla transformer architecture. Will include RMS normalization, rope, swig-loop, KV cache, sliding window attention, and more. Part 4 will scale it up. So we'll go from byte level to BPE byte pair encoding tokenization. We'll add gradient accumulation. We'll explore how to do mixed precision training. We'll do checkpointing, logging. All right, so part 5 will be mixture of experts. We'll do some theory over here. We'll explore the routing, the gating, the stability tricks, and hybrid dense plus MOE blocks. Part 6 will cover supervised fine-tuning. So we'll dive into instruction data sets, formatting prompts and responses, and evaluating outputs. Part 7 will implement a reward model using pairwise preference data sets, and we'll explore a few loss functions like Bradley-Terry and margin ranking loss. And then finally, in part 8, we'll bring it all together with RLHF using PPO, proximal policy optimization, adding a value head to our policy, scoring completions with our reward model, and optimizing a KL penalized objective. This is the same basic recipe that powered the first versions of ChatGPT. This course is designed to be hands-on as possible. Every part comes with a modular, well-commented code that you can run, tweak, and extend. So if you see here, we've got all the parts figured out. I'll link the GitHub in the description. So every part consists of each module that we're going to pick up here. It's all organized into orchestrator.py. That's your entry point. So if I look at part 1, I'll try to find this orchestrator.py. Part 2, same thing goes. So the orchestrator.py will be the starting point of every module, and then you can work your way inside from there. Again, as we'll explore each and every module, things will become clearer. That's the roadmap. I hope you're excited to dive in. Grab your laptop, set up the environment, and let's start building from scratch. Welcome to part 1 of LLMs from scratch. In this video, we'll talk about the overall architecture or the workflow that we'll follow, along with hyper focus on just the transformer part, the vanilla transformers as we know it. So if you look at this GPT assistant training pipeline, and it's split into 4 major stages, and we'll cover all of them in our series today. There's this pre-training, that's step 1. Now, this is where you spend the most amount of money. This is where a sizable chunk of the internet gets processed to tens of trillions of tokens, and then they bring out what is called a base model, which then is used for further processing. This is the step where thousands of GPU and months of training and all of the big models come into the picture. The supervised fine-tuning stage is the second stage from there. Relatively sparse data requirements and compute requirements, and this is where we go from the base model behaving like a purely next token predictor to more like an assistant. From there, the alignment stage starts, where you don't want the LLM to present biased political views or something along the lines of abuse and quality and security. So you come up with a reward modeling step, and then finally
which is something that we're gonna be altering. Every corpo large language model is very sucky. So
The reinforcement learning
be
from human feedback.
Interested.
In this video, we're only going to focus on the vanilla transformer, as the paper in the year 2017, Attention is All You Need, came out with. So we have on the one hand the transformer architecture. This consists of the encoder and the decoder. We'll only focus on decoder only because LLMs are mostly decoder only transformer architectures. So the input is first tokenized, and then it goes through an embedding step, and then the embeddings go through a positional encoding step, and then from there it's split into three parts to Q, K, and V. And the zoomed in version of this box, masked multi-head attention, is over here. So the three splits that we had for the embeddings, they go through their own linear layers, and then a scale dot product attention concatenate the output of all of the heads, all of the different heads, and then finally through a linear layer. Now this is the zoomed in version of the scale dot product attention, where the QKV goes through a matrix multiplication and then a scale component, and then we will use the mask and the filling component because we are focused on the decoder only architecture. So if you were to implement an encoder only architecture, you won't be focusing on this. And then finally put it through a softmax and then matrix multiply it with the V, and out comes so whatever comes out of here is actually this, and then it's all concatenated. So the different heads spit out different outputs that are all concatenated, sent through a linear layer, and then finally whatever comes out of the multi-headed attention is then added, or a skip connection is present with the previous input, and then normalized. So we go through layer normalization in this case, then through a feed forward and out with the softmax and the logits and probabilities. Again, I wanted to keep this a very theory light course, so we'll only go through the bare essentials of what is required so that we can proceed towards implementation. Now this entire block is called the layer of a transformer, and you can stack up however many layers as your desire to implement a bigger and bigger network. So the more layers you apply, the bigger your model gets. So we'll jump right into the code with that perspective, and then hopefully once you see how the attention mechanism and all of the neural network is configured, it'll provide you a better perspective. So we're only going to focus on part 1, and this is the repository layout for part 1. As always, for each part, the entry point will be orchestrator.py, which runs the different demos and the tests, and you can go double click deeper from the orchestrator.py. Treat that as your starting point. So we have the different modules here. So we got the POS encoding, there's a small attention NumPy demo for perspective, what a single head of attention looks like, a multi-head, a feed forward network, what the entire block looks like, the attention mask, and some visualization utils to help you visualize things along the way. So what we first do is we add in this argument for visualize, and it will write out some matplotlib visualizations on our out folder. So if it doesn't exist, we make them, and then first things first, we run the dummy attention demo, but we'll skip that for now. We'll try and understand the actual attention mechanism that we just studied. So it all starts with demo mha shapes.py. So we'll open that up, and first off we import the multi-headed attention, and then we set the hyperparameters for our model. So B is going to be the batch size, T is going to be the sequence length of a particular row of data. You can assume this as the context length. The D model is going to be the embedding dimension, and then we also define the number of heads that are going to be configured in our scale.product attention mechanism. Now the core idea is the D model gets split into the number of heads that you configure here. So if your D model has a dimensionality of 12 and your N head is 3, then each head, it'll first be split into 3 heads, and then each head will be of size 4. So it is essential that they be divisible by each other. Otherwise, an error should be thrown. All right. So we make some dummy inputs. So x equals torch of random distribution, random normal distribution of the batch size, the token sequence, and the D model. And then we pass it through a multi-headed self-attention. So in order to invoke a block for the multi-headed self-attention, we take a D model and the number of heads. That's all that is required. We log things along the way, and once we run this, we'll be able to visualize all of the output. Now what I've done here is written all of the log output in a file so that it can be studied later. So once our attention block is defined, we pluck out the QKV component of it, and then we run it through our input. So imagine this to be the output of the embeddings of text. So whenever text goes into a large language model, it's first tokenized, and then from there each token is converted to an embedding dimension. We will study these two things in great details later down the parts, but we are not going to build tokenizers and an embedding layer in this particular part. So we push it through the QKV part, and then we get our QKV back. Now we'll actually have to split it to get our individual QKVs. So we'll have to configure them right along batch size, token size, and then 3 of n head cross d head. So if you have n number of heads, it will be split along the number of heads that you have and the d head that you have and the combination of the D model. So once you unbind your QKV, you actually can unpack your individual Q and K and V. The Q and K will get transposed, ready to be matrix multiplied, and then we compute the scale. So again, if you focus on the equation over here, then the Q gets multiplied by the transpose of K, and then it is scaled by D of K. Now the DF model is actually the global dimensionality of the embeddings, and DK is the dimensionality of each attention head that you use. So in our case, our embeddings are configured to be of 12 embedding dimension, and then we have 3 heads. So D of K in our case will be 4. So we configure the scale parameter like so. So it's the inverse of the square root of each dimension of a particular head. And then we finally compute this part. So the QK transpose, and then divided by the scale parameter. So we're focusing on the expression over here. So if you see, we are matrix multiplying Q with the transpose of K and then multiplying it by the scale. Now since I've already taken the inverse as our scale, I need to multiply it and not divide it. So I've computed the part where Q and K transpose are computed along with the scale. So I'll take the softmax of these scores and then directly multiply it with the values matrix, which will give me the output. So once I get this output, this is the output of the attention mechanism. I just have to push it through a feed forward network, and then finally I get my output, right? Now we skipped a bunch of steps here. We haven't gone inside what a multi-headed self-attention is and what are all of the different components like the attention mechanism, the QKV, and the project. We'll do that right now. So this file, multihead.py, represents one multi-headed attention module. So this is again importing from the NN module. And the important thing to understand here is the flow or the dimensionalities that change along the way. You'll get an input of batch size, sequence of tokens, and a D model as input. Now, once you push it through the QKV, you're going to make 3 copies of X of the above matrix. So what you will end up with is a batch size token, but 3 times D of model. So you'll get 3 copies of the QKV. And then you push it through the 3 linear layers, and then you get your 3 individual Q, K, and V, where each is n cross head times d cross head for each token and batch, right? So there'll be 4-dimensional tensors over here, and they will be split along this dimension, the QKV. Then we'll have to transpose them and then compute the Q times K transpose and then scale it by the square root. We've already seen this before. What you'll be left with is again a batch of n head cross t tensors. And then finally, we'll have to softmax. We'll have to apply softmax on top of it and then multiply it with the weights matrix, which will give us a batch of n head cross t of head. Again, if you follow the simple rules of matrix multiplication, you'll be able to get this very quickly. And then finally, the merge step happens where we concatenate all of the different heads together. So this will simply be along the third dimension, the number of heads that were there and the dimensionality of each head, which will bring us back to the DF model. So this is the output of every multi-headed self-attention mechanism. If we go through this, we initialize our module through an assertion statement first, and if this itself is not satisfied, it will raise an exception saying the D model must be divisible by the n head. It's a nice guardrail to have. There's an n head which is passed by the user when they are invoking. So in our case, we passed the n head as 3. Then there's a d head, and d head will simply be the D model divided by the number of heads, the quotient part of it. That's why you see the double slashes. Then there's a QKV. So each Q and K and V will have their own set of linear weights. So what this takes as input is a D model, and it has weights outputting 3 times D model, right? So we're going to do this matrix multiplication in one shot. So we don't have 3 linear layers for each of Q, K, and V, but we have one linear layer that represent all of Q, K, and V, and then we'll split it in retrospect. And that's why post the QKV happens, there's a view and a split method that we're going through after this, right? From there, the projection layer is just a linear layer. Optionally, you can keep a dropout. So it's configured to 0 by default, so we won't have dropout unless you configure it explicitly. And then trace shapes true literally gives you some good bookkeeping facilities of plotting and printing all of the shapes so that you can track them along the way. Now, this is what a forward pass looks like for a multi-headed self-attention mechanism. So we have the BTC split into the X dot shape, and then from there it goes through the QKV. We rewire the QKV to unbind it to give us our individual Q and K and V. Then we apply transpose to all 3 of them, and then finally we configure our scale matrix multiply Q and K, and then put it through a causal mask. Now this is the important part where we had mentioned that there's a masking step. So Q and K gets multiplied and then gets multiplied by the scale, and then there's a mask step that is optional, which is nothing but the upper triangular matrix. So this essentially is a Boolean value that will return true if you configure it so, and then that true will change the matrix you apply it on and set it as 0. So let me try and explain this a little more. So what we want to essentially do is, if we have a matrix like so, and this has, let's say, various elements in it, and I want to apply a masked fill, that essentially means the upper half of this diagonal should be set to 0. So this part. So what we are essentially implementing is we invoke an upper triangular matrix that simply says true in these cases. So it's basically a matrix that is filled with booleans, where the elements that we want to essentially remove are set as true. And then when we do in PyTorch what is called a masked fill, then we will pass this matrix over here, configure it with this, the masked fill. We'll see this in a minute. And then what will happen is, whenever this is true, that particular element is set to 0. So if this is true, this will set to 0. If this is false, the element will stay as is and the values won't change. So in our case, we will substitute it with -infinity, because softmax of -infinity simply gives you 0, which again then implicitly turns off all of our parameters to 0. The reason why we do this is in large language models, you essentially don't want to see the tokens that are further away or in the future of the current token that you're processing. So if you have a sentence, the cat sat on the mat, then if you're focusing on this token and trying to go through your decoder only architecture to get an output, you don't want to look at these tokens, right? So if I'm processing these tokens, all I can look at is the previous tokens, including itself. So if I'm processing this token, I can look at everything here and previously till my context window. So by the time I get to mat, I'm probably only looking at this window, right? So if there are words beyond the word mat, I cannot and should not be able to look at them. So that's the core idea of the mask fill. So if we come back to our code, the causal mask function simply returns a boolean of the desired dimensionality, where it fills up with ones, and this will be treated as a boolean for whether to apply a masked fill. So we'll watch that in a minute. So I take my causal mask over here, and then I do the attention matrix that I got from previously, and then I do a masked fill with the mask as the input. So I'm informing where all I want to replace this matrix with -infinity. So where all this mask matrix will be true, the attention matrix, the positions in the attention matrix will be replaced by -infinity. And then when we take the softmax of the attention matrix, the -infinity will go to 0. And that's how we call it turning the attention off, or turning these tokens off. And then finally there's a dropout. Again, in our case, it's not applicable. And then we matrix multiply the weights by the values matrix. Again, if traces is true, we print the shape, we'll watch it, and then we'll reconfigure it to put it through the projection layer. So here we're transposing the dimensionalities 1 and 2, and then making it contiguous. So fun fact, transpose actually breaks memory allocation in PyTorch, and that might be a problem when you're trying to do further processing down the line. So it's actually essential for us to apply this contiguous part, right? All right, so torch.tensor.contiguous is easy to understand. It returns a contiguous in-memory tensor containing the same data that you pass in. If it is already in the specified memory format, it returns the tensor itself. So it will be the same data, but the memory allocation will be contiguous. Now, why do we need this? So the view here will just return the same data, but with the reconfigured dimensionality that you specified. And for view to work, you actually need the matrix to be contiguous. Now, if you want to avoid using two operations one after the other, you can also use reshape, which returns a copy of the data. This is a nice thing to do. It saves us some memory, but I don't think it matters eventually, because contiguous again reallocates the data in memory, and then view just rewires it with the same data. I think you can achieve the same thing through reshape. And then finally, we return the output, which brings us back to our multi-headed self-attention, and everything else follows like we just discussed. So in the multi-headed attention, we went through the causal mask, And that, I think, was the only piece that was missing for us to understand this properly, right? Couple of things that we have skipped is the positional encoding. So let's go through that. So the idea is whenever you send text through large language models, again, they get tokenized and there's an embedding, but they also incorporated with positional embeddings. And this will give it a sense of it matters a word appears in what position. So what we have implemented here is an absolute positional encoding, which essentially means that has the cat sat on the mat, then this position will be given a certain positional embedding, and that will get added to the original embeddings of this word itself. So if the cat has a certain embedding, it will be added to the positional encoding that we have come up with for the even position or the second position. So there'll be one for the third, one for the fourth, and so on. So each position will have an absolute positional embedding, and it doesn't matter whatever word comes, its embedding will be added to that corresponding positional embedding. So how do we calculate the positional embedding? Well, there are two ways to do it. We'll go through the sinusoidal positional encoding, because that's the one implemented on the 2017 paper. I've got one more that you can go through. Again, we'll eventually evolve this to doing rotary positional embeddings, so might not matter. So for the forward, we take what you give me. So this will be B cross T cross D model, and then I'm just adding my positional embedding that I have for those particular dimensions. So I come up with toss zeros. So this is for the context length, and this is for the embedding dimension, and then I arrange them. So this A range goes through 0, max length, and then unsqueeze, meaning it adds one more dimension to this particular vector. And then this calculation, again, it's mentioned on the paper. So I have the original paper open in front of me, and here's what the positional encoding suggests. So we've given a couple of formulas. Again, there's a formula for odd positions and there's a formula for even positions. So depending on the word was seen on the second, fourth, sixth, or the first, third, or fifth, the positional embedding will be slightly different. So here we come up with the division term, and then depending on whether it is the odd position or the even position, we apply sine or cos. Then position times the division term, exactly as it mentions on the paper. And then we register this as a buffer. This is another interesting PyTorch property, which essentially says that this will be used in the forward propagation, but we don't need to store the gradients. So these are not learnable parameters. They are calculated once and they are absolute. So we again take the words, tokenize them, create embeddings, and then from there we add our sinusoidal positional embedding to get the inputs for the attention mechanism. Finally, in order to visualize the attention mechanism better, I've also implemented this in NumPy. So let's say the output of the embedding is our X, will be batch size 1 and a sequence of 3 tokens, or sequence of 3 and a D model of 4. So each token will have 4 dimensions here. So those are the 3 tokens that are coming in as input. I have the linear layers WQ, WK, and WV. So I'll multiply them with the individual ones. Now remember that in our PyTorch implementation, we did this in one shot and then split the QKV we're doing the opposite here, just so you have more visibility into this. And then we finally print the different shapes. We calculate the scale by hand. And this is just, I think, a more simplified and a better view that you can run over and over again in NumPy in order to visualize the attention mechanism better. So feel free to tinker around once you get a hand on this. And then finally, we machine learning engineers, a subset of software engineers, further hate writing tests, but I think they help a lot. So I've written a couple of tests here, and there will be some tests that wherever I feel I struggled with it personally, I have included unit tests so that you can try them on your own as well, just to make sure that the math is correct on this one, right? So the X goes as input, and I come up with random QKV. Now what I'm trying to test for is the shape of it, right? So if I set a seed, I get a tensor X, so I create a torch tensor out of my NumPy array. There's a single head self-attention mechanism that I've implemented here. So this is what it does. So it's basically a subset of the multi-headed self-attention, where we don't do the multiple heads. It's just one single head. It's just a simplified view of the multi-headed attention, right? So if I come back, so we take a single headed attention block, and then the Q in the single head self-attention will be filled by these weights. So the WQ over here will be copied over to the weights of the Q that we have configured here. Again, if I open the single head, one of the components is the Q part. So the weights of this linear model will be copied over to the Q part in this attention mechanism. So the same goes for K and V. And then finally we run it through the attention mechanism to get the output and the weights. And then we assert that the shape is going to be 1, 3, 2. Again, based on our inputs, this should be the right answer. And then hopefully everything works out. So what we'll do now is also go through some visualization utilities that are written. I won't be going through them in detail, but this will help us visualize attention better. So without further ado, we'll actually run the code and then see the output for ourselves. So I'll go Python orchestrator demo, and then I will pass it through the visualize parameter. So again, if I come back to the orchestrator, all of the instructions on how to run and what to pass are given over here. So I'm already inside my part 1 folder. This is where you need to run it. And then once you run it, it runs the attention NumPy demo that we've already seen. So it goes through each and every matrix, giving you complete white box visibility into each shape, so that you can visualize it yourself. And then finally, we run our demo multi-headed attention shapes.py. So the input over here goes as 1, 5, 12. So where 1 is the batch size, 5 is the token sequence, the number of tokens, and 12 is the embedding dimension of each token. Now, if you push that through QKV, what you'll get is 3 times what was there before. So 1, 5, 36, that checks out. Now, if I have to split it into QKV, I need to view it in 5 dimensions. So I take this and I split it into 1, which is the batch size, 5 again is the token sequence, 3 is literally hard-coded to Q and K and V. The second 3 is the number of heads, and 4 is the dimensionality of each head. And then from there, each Q, K and V will be 1, 5, 3, 4 respectively. Again, if I transpose only dimensions 1 and 2, so these 5 and 3 get swapped to 3 and 5. So we'll get 1, 3, 5, 4. And then from there, if we multiply Q and the transpose of K, then we'll get 1, 3, 5, 5. Again, Q with the transpose of K. So this dimension, along this dimension, if we multiply, then we'll get 1, 3, 5, 5. And then finally we apply the softmax. That does not change the dimensionality. Then we'll multiply it with the v, and v is again 1, 3, 5, 4. We multiply that with again 1, 3, 5, 5. If we do that, we'll be left with 1, 3, 5, 4. Then we merge each of the heads. So with each head, we'll get 3 separate 1 by 3 by 5 by 4 matrices, and then if we concatenate them along the dimensions, then we'll get 1, 5, 12, and the final projection will be 1, 5, 12. And then we included a small legend for each of the acronyms and what they stand for. And then there's an entire visualization module as well. So if I come back to VS Code, you will see that there's an out folder which also logs everything to a file so that you can view it. It's more organized that way. And then for each head, we had 3 heads, remember. For each head, the key and the query have been put together as a scatter plot. Now, since again we are using a decoder only LLM, you'll see that the upper triangular part has been turned off. So for each token, so we had 5 tokens going in, so 0 to 4, you'll be able to visualize the strengths of the weights between the key and the query, and that will again give you more perspective on what you're doing, right? So that brings us to the end of the first part. So we started with the decoder only attention mechanism. We have not covered tokenization and creating embeddings. Should be fairly simple, but we've parked it aside for later down the parts. We went through the most vanilla positional encoding. We opened up the masked multi-headed attention to understand the QKB and the concatenation, all of that. And then we opened up the scale dot product attention mechanism as well. Went through a bunch of math, and hopefully now you have good perspective on how to implement your own attention mechanism with PyTorch. Hello and welcome. Welcome to part 2.
Whoa. Let's put a hole on this one. That's a lot. And I think I get most of it. But the moment, whoa. Let's take a break, shall we? 30 minutes of maths. I think we deserve a bit of a break. Bro. Oh my gosh. Oh my god. Looks bad. I'm cooked. Guys, let's take a break from here for just a bit, man. Let's just take a break, you know? Let's take a break. Yeah. Let's take a break. Good break. A good break indeed. I'm tired. I'm over very, very tired. I feel like... BRB, I just realized I'm in the wrong thing as well. I'm sorry, guys. I'm good to my stream manager and myself in software development. It was dreaming full. I didn't think I'd be in art. Sorry, guys. That was my last one. Software and development. There we go. Done. Software and development. Done. Yeah, wonderful. Cool. Alright, I'm gonna I don't know. BRB, guys, BRB. Be right back. Man, everything's running on full blast, man. Everything's running on full blast. Anyways, what was I gonna do? Yeah, alright, BRB. I'm gonna grab something to drink or something. I don't know. Hey there, guys. Or I'm gonna save this one. I think we're gonna do this later. Let's go back to the normal stuff. So save moments. Rid of that. And alright, so build this. Let's test some things. Actually, was it this one that we used? I don't even know. What I used? 53.49. Hey. Hello. I want to know what's going on. How do you make pasta? Okay, but describe to me the step-by-step instructions on how to make pasta. Try and get a better text-to-speech one. Sorry. Alright, we'll try this one. I'm gonna try whisper, guys. using Whisper anyways, actually, by the looks of it. Interesting. It's all recording loop, guys, from what I can see here. This is quite tricky, which means I have to figure out some sort of way to go around this. So in this case and scenario, what I'd say is that this is okay. One thing we'll do, alter the speeches. So okay, so we can remove this. Back to here. I wanna just run everything real quick. I wanna just rinse F previous text. Alright, so let's go down. Let's start all of this back up again. Oh, tell me, son, what's your name? Now I say what? Tell me the truth. Did you steal those cookies? The previous text is not being taken yet. So previous text. And then previous text, and then current text. But for some reason, we do print the previous text. Why is it being? Nothing's there. Interesting. Let's see this. What is being generated here? So if we do current text. Print. Oh, well, we already did print the current text there. So, get a bigger sample. Maybe 5 seconds. It's 5 seconds. It's not in relation to when it starts. The sample rate. Everything is using Google, man. So let's look at several things here. So previous X, current X unknown. So this is with as soon as it starts. What we'll do is I will try. Whilst this is true, let's pull the audio from Q. While the audio is not empty. So what we can do, instead of recording the seconds, right, so we can do this. Whilst the audio cue is no. Okay. When the audio cue is not empty, it means that there is sound. No. Clear all outputs. Clear, cancel. Okay. Whoa. Where I forgot where we were. Okay. So pulling the audio from Q, right? So let's look at audio Q Python. Let's look at that. Audio Q Python. Alright, so Python audio Q. Audio Q Python. What is the audio Q though? Data to copy. Audio callback. Time frame. Yeah. Collect audio chunks from the mic. Okay. So this is collecting audio chunk from the mic. So we haven't touched anything yet. So as we collect audio chunk from the mic, right? When the audio is not empty, it means that there is sound. So what we can do here is that to prevent early cuts off, we can start a timer until the audio queue is empty. So Python timer. Do I make a timer? 10 code. What was it type? Python timer. Import that time. Python timer in seconds. That's not your code. Time, the access time conversions. That's time dot time minus dot time. So and then times time per second in Python. So let's get. We'll try to do it in. We'll try to do the max. So what we'll do, right, is we pull the audio from the queue. Alright. No, wait, no. So wait. Hold on. Wait a minute. Okay, so we'll do you try. And then while it's true, we're always pulling audio from the queue. So while the audio queue is not empty, right? Then Now I'm getting mixed up a bit. Let me get the timer thing first. Python time your code in seconds. So gonna do recording time is equal to, so the start time is equal to time dot time. Alright, now what we're gonna do here is that we're gonna go all the way here. For old modules, we're gonna import time. That's one thing is all that we're gonna do. So time dash time equals time. Now, one thing we're gonna need to do here is timer for how long the ordered segment is. Okay. I hate this. Cancel. Okay. So time to how long the recorded time is. Know that this is start time. Right. Start time is currently 0. That's that. So start time? Nothing at the moment. this is the there. Start time, dot time. As soon as this starts, start the clock. Now, when this is done, whilst empty, this means is no more audio to be processed. We can then calculate the length of time using seconds is therefore the below formula. So this stop. Therefore the below formula. Where is that? Therefore the below formula. So below formula is therefore and record seconds. So actually we'll do a thing as well. So end time is equal to time dot time. Right now total time equal to time dot time in seconds. Seconds since the epoch. Fractions of similar presence. Time method. Focus in seconds. Strip time. Okay, we're gonna do Python time module. You tell me how to do it 2 seconds instead. We convert it to the string, return current time in seconds, nanosecond epoch, spend time equal to seconds into epoch. 10 Okay, let's see. Oh. dot 2f. Okay, let's do dot f. Yes. So total time is therefore end time minus start time, and then of course this is also total time equals total time dot 2f. Oh, okay, wait a minute. Sorry. Dot f. No, equals total time dot f. Hopefully this will work. Dot f seconds. So we need to first do this. F total time this dot 1.0f. To int hyphen. Yeah, or we can just do int. This seems cursed. This seems cursed. I wanna. What happens if we do this? No, we need to do. What all if we do float? Float. X float 3.5 dot roof. Opposite of floor function in Python. Sort of a floor function is equal to floor and ceiling file to the nearest integer. Okay. So, actually, what if we do dot ceil? Let me do that. The nearest integer. Right? No, there's no. Let's see. X equals 3.5. Right. What if we do x equals x dot ceil, and then dot print. Anything called that. What is ceiling function in Python? What is the ceiling function in Python? Floor ceil. Math dot. Oh, okay. It's math dot that. Okay. Math dot ceil, math dot floor. So reality is int and then math dot ceil and then this. Math dot ceil. Oh, we don't have import math. Wonderful. So we don't have to do this. So what we can instead do here is import maths. Import math. And then in math we do simply as int math dot math.seal. Right, and then we take those two, put it into that. Now that's a thing. The total time, and then the record of the seconds is equal to the total time. And then this one go like this. So this should now work, and there should be no issues at all. Actually, I think this should solve it. So let's try this out. Let me run all real quick. Can't believe me, this took me a while to figure out. I'm like, hold on a minute. This is what happens when I use Alphabet's codes. That is a major breakthrough though. This is like a major breakthrough to prevent stuff from going wrong. Hello, my name is Gabs, and I absolutely love you, and you are an amazing person. That's weird. Can you tell me more about yourself? Let's go print record seconds. Well, I can see you absolutely love it here in the Outer Ring. How can I be resistant with that Outer Ring coolness? You know, sometimes I love it really quiet. Hello. Hi. Hey there. So, are we gonna go out somewhere tonight or what? Okay, now it's just too sensitive. Now it's just way too sensitive. So let's interrupt this. And let's try to do several things here. So if we look at the modeling side of things, it's been hitting it alright. CPU has been quite heavy usage. Now I'd say okay. We need a bit of a buffer here. More than 1 second buffer. Because 1 second is too quick, so a record of seconds plus 2 I think should do. Oh, maybe let's see, start time. So now we know that there's audio coming through. Right. So 0, 0, 0, 0 audio. And then so let's see. 0, 0, 0, 0, 0 audio isn't here. Start the timer. Get the data from the queue. Now, where is the data coming from here? We have data here. Wait a minute. I feel like we're putting this in the wrong spot. I don't see a data thing in the other spots here at all. So that just be local. The local for that is alright. The buffer, but potentially I'm just thinking right now would be best. Start time. What if we just what if we do this? And then instead of that, we're doing if statement. If that's not empty, then we start the time. And then while it's not empty, dang, stop doing that. While it's not empty, that's not empty. Dang it. While is not empty and we still need text sound, we wait to build the start, we build the recording time. So what is Python wait function? Time dot sleep 1. Time dot sleep 1. Once no longer detecting audio, then we can get the entire audio queue. Alright, so how does that sound? Let's restart that. So I wanted to know if this would work. What do you think? Hey, you there? Hello? Now I've broken it. But it is adding it to the buffer though. So in that case, what we should do is this then. Do that here. Simple. So this one, this one. Now actually so this should work. Whoa, hey buddy, it's been a long time. Hey. gonna be a while. This is not empty. This is gonna be hard. Why is this so hard to fix? Hey man, you know I've always wanted to listen to you, right? Something's wrong. Hello? Hello? Did we break it? Shouldn't be though. That's interesting. Wait a minute. Is it? I see, alright. Might be impacting it actually. So while let's try this. Oh, you know, just the casual stuff. Life is pretty hard sometimes. I could really use a friend, you know?
hope that someday someone would love me.
Did you know that Wendy's is now selling popcorn, chicken, butter chicken, and everything else in between? That's weird. Why is it still being like this? Printing out the current text, but look at the thing, like, no. Let's get rid of this for a minute. Oh, hey, Daniel, how you doing, man? What the what, man? What do you mean you're stalking me? Athena, can you contact Fairy? Athena, can you please contact Fairy from Zenless Zone Zero? What's 1 plus 1? Hey, can you please contact Fairy from Zenless Zone Zero? Athena, what's 1 plus 1? Athena, I said, what's 1 plus 1? Something is going on here. That doesn't solve it. I'm not sleep. Stops. Instead, what we can do is start time is 0 while the key is not empty. Let's do start time plus 1 plus equals 1. Athena, can you contact Fairy from 111? Hey Athena, please contact Fairy. Athena, what is 9 plus 10? What is this? Something's not sure how to fix this. You'd think it'd be fixed, but no, not really. We know this has to be like plus 1 second. That's one thing for sure. I've got to turn on the light, guys. Hold on. Open AI Whisper. Okay. Let's go with several things first. Required VRAM is 6, so let's try turbo. That's one thing. Da 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 da. Oh, it doesn't. Oh my gosh. Turbo. Let's go. Let's run. I need more VRAM. This ain't good. This ain't good, boys. Alright. Should be coming up now. I got turbo. Gracias. Hello there. Okay, now we are having some other problem here. We need to edit things around. I'm starting to think that it's getting the other things that are having issues. So let's see. Call LLM. Probably the ones having issues. Call LLM response. Up to previous current text. Yes, okay. That's not it. So we don't need to worry about that. No, it is getting. Alright. It's weird. And what is causing this to have issues then? Hold on, guys. Hey guys, I might be right back. I'm gonna have dinner right now. BRB, guys. Alright guys, I've actually decided I'm actually going to be taking a break off of stream. At this 8, so I'm like chilling. So I'm just going to be doing some kitchen or something, I don't know. Alright, bye bye. Yeah, have a good one. I don't know, Kev, if you're watching, but yeah. Have a good one, guys. Bye bye. I'll see you guys later. I think this part is pretty much all done. I don't think there's any more we can do in trying to fix this thing. It's just really hard to do. We'll see about it, but I can see that my computer's struggling to handle a lot of the stuff. We need a whole lot more things working on it. That's what it looks like. That's what we need for the inference. But yeah, at the moment there's not much we can do. I think try to optimize it as much as we can, but I'd say this is pretty much all optimized. As optimized as we can get it. So yeah, I'm just gonna chill out with some games. Bye bye. Take care.